So today we are going to discuss about the origin of magnetic field. As you know that there are three fields. One is electric field, another is gravitational field, and the new one is the magnetic field. As you know that this electric field can be produced due to a charge, due to presence of a charge. There is a charge, point charge Q, and there is a point P at which you want to know the magnitude of electric field. You have the formula E is equal to kq by r square, and that k is 1 by 4 pi epsilon, that is 9 into 10 to the power 9 SI units. Similarly, there is a point mass. You want to observe the value of gravitational field at point r, and that is gm by r square. Value of g is known as 6.67 into 10 to the power minus 11 SI units. But magnetic field is not so simple. It is sorry to say that magnetic field is not so simple. It is not like kq by r square. It is not like gm by r square. It's not a very simple expression. Actually, you have very complicated equation. This is called Biot law. If a point charge q is moving with velocity v, and you want to calculate its value of magnetic field at a point P whose position vector is r, then the formula for the magnetic field is mu 0 by 4 pi into qv cross r by r mod of r cube. Value of mu 0 by 4 pi is 10 to the power minus 7. So as you can see that there is a very simple formula for electric field, that is kq by r square. Very simple formula for this gravitational field, gm by r square. Actually, you can say that this formula is also simple. Actually, when v is perpendicular to r, then angle becomes theta. Then v cross r is vr sin theta, and sin theta is 1. So you can say for theta is 90 degree, b is mu 0 by 4 pi qv r by r cube. So 1 r cancelled out. So we'll get mu 0 by 4 pi qv by r square. But very interesting to know that there is no expression of velocity in these two terms. There is only q and there is only mass, kq by r square, and there is gm by r square. But here some constant into q by r square, there is v also. So it is very important, it is very important to understand and to calculate the magnetic field at a point P. So similarly, you can say that you can talk in terms of current, that there is a charge q which moves with velocity v. It covers a distance dl in time dt. It creates current I. So you can say qv is just similar to idl, because dl is velocity into time. So you will say I into v dt, and this I dt was q. So you will say qv. So in future we will frequently use qv in place of ideal, right? So you can say that this formula, this Biot law, was dB was mu 0 by 4 pi qv. Earlier you had qv cross r by r cube. In place of qv we can put ideal. So there is a current element ideal. Very small part dl is length of the current, length of the conductor carrying current. So I is not vector, but I dl together is a vector quantity. It is called current element vector. You want to calculate magnetic field at point P whose position vector is r vector, so that this ideal is origin. This ideal is very small. So this ideal is origin, and you want to calculate magnetic field at point P. So dB is mu 0 by 4 pi ideal cross r by r cube. There are good and beautiful problems on this concept. They give you the location of this point P 2, 3, 5, and the position of this point 1, 2, 3. So you get the r vector and you get the ideal here. So you can take the cross product simple. So it is very simple that whenever you want to calculate electric field, you use formula kq by r square. When you want to calculate gravitational field, you use gm by r square. And whenever you want to calculate magnetic field due to moving charge, A charge at rest produces only electric field. A charge in motion produces magnetic field also. A charge in motion constitutes magnetic field. It has magnetic field at point P. It will show. So B is mu naught by 4 pi QV cross R by R cube. So it is very interesting to know that in place of QV you can put ideal. So this is Biot law. Magnetic field at point P, whose position vector is R, due to a current element ideal. So you should remember this formula. It is very important. This is Biot law to calculate a magnetic field at point P. dB is mu naught by 4 pi ideal cross R by R cube. So let us come to, there are some formulae here. So we will use them frequently in our questions. So there are, I think, only 5 to 6 formula here. So we will start from this one. There is a circle having current I. Radius of the circle is R. You want to calculate magnetic field at the center. So actually some students say that there is no battery and there is no resistance. How can we say that there is current? But actually battery is not shown here. There is battery. This wire has resistance. So this this system has battery and resistance also, but there is no meaning to show them here. So we can say that there is a circular wire having current I and whose radius is R. You want to calculate magnetic field at center. So there is simple formula mu naught I by 2R. You have to learn this. Actually, there's no pi inside on the numerator, or there is no pi in denominator. So actually in future you will learn that there is a infinite long wire. This is infinitely long wire, and you want to calculate magnetic field at point P. So you want, this formula is mu naught I by 2R. The same formula, but pi is here. The difference of pi is here. So in this circle case, in case of this circular ring having current, there is no pi in numerator or denominator. So it is very important to learn magnetic field at center is mu naught I by 2R. We are going to solve around 20 problems on this basis, so that you can solve problems in your JEE or NEET or in board exams. So I'm taking one by one. Okay. So problem number 1. Here is a, you can say, here is a complete circular ring, and current flowing in this is I. You want to calculate magnetic field at center. Obviously you will learn the formula. It is mu naught I by 2R. How can you get the direction of the current? See, you take your right hand and curl your right hand fingers along the sense of current. You take your right hand and curl your right hand fingers along the sense of current. Your thumb, extended thumb, will give you the direction of magnetic field. So in this case you curl your right hand here like this, and you will get magnetic field into the paper. This direction is called into the paper. This direction is called out of the paper. This is inside the paper, inside the plane of paper, right? And this is outside the plane of paper, right? So magnetic field at center is mu naught I by 2R. And when there is a half circle, there is current I, and this circle is semicircle, it is carrying current I. So what have you to do, that there is a full, if there were full circle, it will be mu naught I by 2R, and the fraction half is should be multiplied with this. So mu naught I by 4R, right? And in this case it is quarter circle, it is 90 degree. So magnetic field at center will be you write the expression for complete circle, mu naught I by 2R. Now it is 1/4 of the circle, so you just multiply by that fraction 1 by R. So you will get expression mu naught I by 8R. So we have to calculate magnetic field to these systems. So you will write for this case mu naught I by 2r is magnetic field due to complete circle. And now 60 degrees is 1/6 of the circle. So you will multiply it by 1/6. It is the answer. Direction is just curl your fingers and this thumb is into the paper, right? Now this 45 degree is 1/8 of the circle. So you will write that mu naught I by 2r is due to complete circle, full circle, and into fraction of the circle, 1/8. 30 degree is 1/12 of the complete circle. So answer will be mu naught I by 2r into 1/12. This is the way we calculate the expression for magnetic field. Now we should come to next question. So it is 1 degree here. So you will say magnetic field at center is mu naught I by 2r, right, into 1 degree is 1/360 part of the circle. It is very interesting. So this is magnetic field at center will be mu naught I by 720 r. Or in general you can say, if there is an arc, there is current I in that arc and it subtends angle theta, at the center. Theta is in radian. So you will say that magnetic field at center will be equal to mu naught I by 2r is complete circle, magnetic field due to complete circle, into fraction of that circle, theta by 2 pi. इतना हो गया, ठीक है. Note, if a current carrying straight conductor is extrapolated, if you just extrapolate it, then magnetic field at all points along this line is 0. If a straight current carrying conductor is extrapolated, then magnetic field at all points along this line is 0. There is a straight conductor having current I. Now you extrapolate it. There is a point P. Obviously I is parallel to R. They are in the same direction. I and R are having same direction. So ideal cross R is 0. So magnetic field at P is 0. Because you have formula mu naught by 4 pi ideal cross R by R cube. You see ideal and R are parallel here. Ideal is in the same direction as the R. So magnetic field at P is 0. Ideal cross R is 0. Now we want to calculate magnetic field in these two cases, right? Now first I will consider this case. This conductor has 4 parts. Part A, part 1, part 2, part 3 and part 4, right? You can say that magnetic field due to part 1 and part 3 at center is 0. You can say that magnetic field at part 1 and part 3 will be, due to part 1 and 3 will be 0. See, if you extrapolate this conductor, this point lies on this. So magnetic field due to this part is 0 on this, and if you extrapolate this, due to this part will be 0 on this. So part 1 has 0 effect on this, part 3 has 0 effect on this. There is no effect. Now we consider part 1, right? For part 1, you see, curl your right hand fingers along this. For part 2, right? So B2 is in which direction? B2, curl your right hand fingers, then thumb goes inside. It is into the paper. How much? It is half circle. So it will be mu naught I by 2r was the due to complete circle into half. And this is B4. So B4 is in which direction? You curl your right hand fingers along this fourth one. So your thumb goes outside. So B4 is out of the paper. So you will get mu naught I by 2r into 1/2. Obviously R will be A here and R will be B here. So you will write here here you will write A and here B. So it will be mu naught I by 4A this will be mu naught I by 4b, right? So you will get mu naught by 4 common into I. Since A is smaller than B, so 1 by A will be greater than 1 by B. So this will dominate. So answer will be 1 by A minus 1 by B. This is closer. Part 2 is closer to the center. So it will dominate. So net field will be into the paper. This much. See here. Here are 4 parts. Due to this part, magnetic field will be 0, because if you extrapolate this, it passes through point O. Due to this part, it is 0. So there are left only part 1 and part 2. Due to part 1, magnetic field is outside the paper. Due to part 2, it is again outside the paper. So again here magnetic field will be add up. They will not subtracted. So answer will be the same, mu naught I by 4 into 1 by A plus 1 by B. In this situation, the magnetic field will add up. I curl your right hand fingers along this, it goes out. Curl your right hand fingers, it goes out. In this case, as you curl your right hand fingers, it goes in, and for this it goes out. In this case, these two cases, in this case, these two semicircles have magnetic field at center in opposite direction, and in this case, due to these two semicircles, magnetic field at O is adding up, and that is up the paper, right? So now let us calculate this question, magnetic field at O. So obviously it is the case, you will write mu naught I by 4r 1 by A minus 1 by B. As you know, value of mu naught by 4 pi is 10 to the power minus 7. So I will write here mu naught by 4 is pi into 10 to the power minus 7, and I is 1 ampere, and 1 by A is how much? 10 centimeter means 0.1 meter minus 0.2 meter. So you will get pi into 10 to the power minus 7 into 10 minus 5. So you will get 5 pi into 10 to the power minus 7, right? You will get 5 pi by 10 into 10 to the power minus 6. So there is pi by 2. This is pi by 2. This is micro. Pi by 2 micro Tesla. Tesla is unit of magnetic field. So answer of this question is magnetic field at center is pi by 2 micro Tesla. You have to calculate magnetic field at this point O. There are 4 quarter circles with different radii. Radii of first part is R, 2R, 3R and 4R. You have to calculate magnetic field at O. Due to all these straight parts, magnetic field at O will be 0, because when you will extrapolate it, it will pass through O. So magnetic field at O will be 0. Now this is part 1, this is part 2, and this is part 3, and this is part 4. So all parts will have a magnetic field at O in the same direction. Just you just observe, you curl your right hand fingers in this sense of current, you get magnetic thumb inside. For this you get thumb inside. For this you get thumb inside. For this you get thumb inside. So all the magnetic fields are adding up. So you will calculate magnetic field. For a quarter circle, magnetic field formula is mu naught I by 2r. It was due to complete circle into due to quarter circle 1 by 4. That is mu naught I by 8r. It is magnetic field due to a quarter circle. But there are 4 parts and they have different radius. So we will take this much common. So mu naught I by 8 is common, and 1 by r for this one. For this one it is 1 by 2r. For this one it is 1 by 3r. For this one it is 1 by 4r. So you will get mu naught I by 8r into 1 plus 1 by 2 was 3 by 2 plus 1 by 3 plus 4 by 1 by 4 was 4 by 12. So you will get this is 12 by 18 by 12, 25 by 12. So you will get 25 by 96, 25 by 96 into mu naught I by. So magnetic field at center is this much. You can calculate by yourself. There may be calculation mistake, but you have to understand that magnetic field will be calculated like this, and all the field will be add up. See, now in this case, you have to calculate magnetic field at O. So there are 4 parts. Due to all these straight parts, magnetic field at O will be 0, because if you will extrapolate them, then magnetic field will be 0 at that point. So for this one, what formula you will use? Mu naught I by 2R was due to complete circle. It is 1/4. So you will use formula 1 by 8R. Now magnetic field due to this part is due to this part is coming out of the paper, and due to this part is going into the paper. So if this is, I will say 1, I will say 2. B1 is in which direction? Simple. B1 is out of the paper, and B2 is, you will say B2 you will say like this, into the paper. So magnetic field B2 is into the paper. So B net will be equal to, obviously, which is closer? This one is closer. So B1 minus B2. So magnetic field will be out of the paper. Its magnitude will be, you use formula mu naught I by 8, and for R, first you write 1 by R minus 1 by 2R. So you will write, it is mu naught I by 16. This is magnetic field at center. Now come, here are 3 portions. This 3 arcs, it is in XY plane. There is no change in plane. This is kept in XY plane. It is a wire which has some parts. This wire has like this. It starts from here, A, B, C, D, E, F, then again A, right? So this is the wire. So I will say you have to calculate magnetic field at O. You see, magnetic field due to all these straight parts will be 0 at the center, because if you extrapolate, it passes through center. Every arc is making angle 120 degree. It is given in the problem, right? So it is 1/3. What formula will you will use? Mu naught I by 2R was magnetic field due to complete circle. 120 degree is 1/3 of the complete circle. So you will multiply it by 1 by 3. So it is mu naught I by 6R. Now magnetic field due to all portions are adding up. See, it is in the clockwise direction. So it will be this clockwise direction adding up into the paper. This is clockwise into the paper, clockwise into the paper. So magnetic field is into the paper, and you will add all the magnetic fields. So answer will be mu naught I by 6R into 1 by 1 plus 1 by 2 plus 1 by 3. So whatever you will get is the answer, magnetic field at O. Now in this case, due to this structure, you have to calculate magnetic field at point O. See, due to all these straight part, this part, this part, this part, magnetic field at O is 0. So there are only, number 1 is this circle, number 2 is this circle, number 3 is this circle. There are only 3 curved parts. So let us calculate. Let us first of all see what is direction of magnetic field. So curl your right hand fingers along the sense of current here like this. It is into the paper. So B1 is into the paper, and B2 is, you curl your right hand fingers here for the B2, it comes out. So B2 is out of the paper. And for B3, it is again, you curl your right hand fingers, it is again inside. So B3 is inside. Who is getter? Who is more? So if your answer should be B1 and B3 are into the paper minus B2. So your answer will be this much, B1 plus B3 minus B2, because B1 and B3 both are into the paper and B2 is out of the paper. So your answer should be this much into the paper. It should be your answer. As you can see, now let us find the magnitude. B1, B2 and B3. B1 is you will use formula mu naught I by T. B1 1 is, this is 3/4, it is 3/4, right? It is 3/4 into 3/4. You will write mu naught I by 2r into 3/4. For B2 you will write mu naught I by 2r, formula of complete circle. In place of r you will write 2r, mu naught I by 2r. R is formula, 2 is due to formula, and r is 2r into this 2 is half circle. It is half circle, so you will multiply it by half. B3, for B3 again you will write formula mu naught I by how much, 2r, and for r at the place of r you will write 3r, because there are chances of mistake here, because as we learned the formula mu naught I by 2r, then if we write the formula for the third one, there may be a mistake that we straight write like mu naught I by 2r, but in place of r you should write 3r, and this number 3 is 3/4 of the circle into 3/4. So your answer should be B1 plus B3 minus B2. You have to add this one, right? So it is, so you take common mu naught I by r, you take common, right? You take mu naught I by 2r, you take common. So B1 plus B3, B1 is 3/4 plus B3 is mu naught I by 2r, you have taken common, 3 cancels out, plus 1/4, and minus B2, you have taken mu naught I by 2r common, it is 1/4 minus 1/4. So you will get your answer, this cancels out, and your answer is 3 mu naught I by 8r. So you should be very careful whenever you are using the formula. When you are using the formula mu naught I by 2r, don't write mu naught I by 2r, you just stop there and you use what is the value of radius. In this case value of radius is r, for case 2 it is 2r, for case 3 it is 3r, right? First of all you have to use right formula, then you have to use right value of radius, and secondly you have to write the fraction of the circle, like this one was 3/4 of the circle, this 2 was half of the circle, and this 3 was 3/4 of the circle. Then you have to you have to find the direction of magnetic field, and when these, for getting magnetic field, you curl your right hand fingers along the sense of current, you will get the direction of magnetic field. So here B1 plus B3 minus B2. This was very important problem, and I will suggest you to stop the video, to pause the video, and just do it by yourself. Use first of all you should know the formula for magnetic field. Second, you use the right value of radius there. Third, you should know the direction of magnetic field. Fourth, you use the right fraction. So there are 4 chances of mistake here, 4 chances. First is you may use wrong formula. Second, you may write wrong value of radius. Third, you may get the different direction, wrong direction of magnetic field. And fourth, during writing the multiplying by fraction, you may multiply by wrong fraction. So there are 4 places where you may make mistake. So you should pause this video, do it by yourself, and find the answer. Okay. Now consider this. There are 1, there are three circular arcs, right? You have to find magnetic field at center. See, you can say that the two parts which are straight, due to them magnetic field at center will be 0. Due to this straight part, magnetic field at O will be 0. Due to this straight part, it will be 0. So there are part number 1, part number 2 and part number 3. As you can see that is goes out like this. There is no change in direction of magnetic field. So you can write that all the direction magnetic field will add up. See, you curl your right hand fingers along the sense of current, thumb is inside. For this curl like this, thumb is inside. For this curl like this, thumb is inside. So in all cases, in these three cases, magnetic field will be added up. So B net will be B1 plus B2 plus B3. Now you write the right formula. B1 is for this mu naught I by 2R, and it is 1/6 of the circle. 60 degree is 1 by 6. And for B2 you will write mu naught I by 2R. R at the place of R you will write 2R into 120 degree is 1/3 of the circle. And for B3 you will write mu naught I by 2R formula, and in place of R you will write 3R into, this is half circle, so you will multiply it by half. So for the first part it was making angle 60 degree, subtending angle 60 degree at the center, so you have multiplied by 1 by 6, it is sixth part. For the second part it is subtending 120 degree, which is 1/3 part, and for the third part it is making angle 180 degree, it is semicircle, it is half circle, so you are multiplying it by half. So just you take the things mu naught I by 2R out and calculate what is the answer. So and you get the answer. Let me see what is the answer so that you can check yourself. Its answer is I think mu naught I by 4R. Its answer is mu naught I by 4R. So you can check it by yourself, right? You add all these three magnetic fields. Now you have to calculate magnetic field here. In this case also magnetic field are added. Due to these straight parts, magnetic field at O will be 0, and there are two circular parts having same radius R and two circular parts having same radius 2R. So you can say the magnetic field to every part will be added. So these two will make half circle, and these two will make half circle, right? And current is having this direction. So magnetic field due to this is mu naught I by 2R into half. For this magnetic field is mu naught I by 2. For R you will write 2R into half. So your answer will be mu naught I by, you just take 4R common, so you will get from here 1 plus 1 by 2, that is 3 by 2. So your answer will be 3 by 8 mu naught I by R. So this is the magnetic field at center. So you have to observe that these two parts are making half circle together, and these two parts are making half circle together. Now consider this question. It has three parts. Now this straight part is not going to create any magnetic field at the center, and this straight part is also not going to create any magnetic field at center. So we are left only with our this arc. As you know, magnetic field at center is, due to complete circle, is mu naught I by 2R, and this is 60 degree, which is 1/6 of the complete circle. So its answer should be like this, mu naught I by 12R. Now you consider this one. There are 8 parts, you see, one circular arc, other 2, 3, 4, 5, 6, 7, 8. There are 8 circular arcs which are making equal angle at the center. It is given in the question. So you have to calculate magnetic field at center. This is question of IIT-JEE, and it's very simple. You can say these 8 parts are making angle 40 degree, but equal angles at the center. So if you divide a circle into 4 parts, this is 90 degree. If you divide in 8 parts, one part is 45 degree. So one part is subtending angle 45 degree. So there are 4 parts. 1, 2, 3, 4. These 4 parts will make, outer parts will make 180 degree at the center. And these 4 smaller one, 1, 2, 3, 4. These will make how much? 180 degree. So this is the problem. Very simple problem. So it is 1/8. This is 1/8 of the circle. 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 So as all these arcs having larger radius, there are 4 arcs. So 1/8 into 4, that is half. Due to this, it is half, and due to this, it is half. So its radius is r. Its radius is 2r. So you will get magnetic field as mu naught I by 2r at for this into half, plus due to this one mu naught I by 2 formula, at the place of r you will write 2r into half. So you will write mu naught I by 4r into 1 plus 1 by 2, that is 3/8 mu naught I by r. It is very simple. So this problem first at its first appearance, it looks very difficult, but it is very simple, because these 4 smaller parts will make a semicircle, and these 4 larger parts will make semicircle. So you will get this formula, this structure, and you can get easily the magnetic field at center. Now it is very important note, and it has been asked many times in JEE and NEET also. So see, if there is a uniform wire, right, and there are 2 points here and here, and current is not going like this in same everywhere. You have divided this circle into 2 parts. One part is making angle theta, another part is making 2 pi minus theta, right? So obviously the smaller part will have a small resistance, because this wire has resistance, and this larger part has large resistance. So current will not be equal in both sides. I1 this side, I2 this side. These 2 are parallel. So you will say delta V across this equal to delta V across this. I1 R1 is I2 R2. So when you will get magnetic field at this point, then you will say that that magnetic field will be 0, whatever be the value of theta. So irrelevant of the value of theta, magnetic field at O is 0. It is very simple, you can prove it, because due to first part, magnetic field will be mu naught I1 by 2R1 2R into this theta by 2 pi. It is out of the paper. Similarly, you can write B2 is equal to mu naught I2 by 2R due to complete circle into 2 pi minus theta by 2 pi. But as you can say that I1 R1 is I2 R2, and R1 is proportional to, this resistance is proportional to theta, because its length, R is rho L by A, and which has, R is rho L by A, right? And rho arc is angle into radius. So you can write theta here. So you can say that these two values, I2 into this and this will be equal. So magnetic field will be cancelled out and it will be 0. So it is very interesting, and it is very interesting result that whenever there is a uniform wire and you have taken 2 points across which you have applied a battery, put a battery, and then this current comes and it divides into 2 parts, and magnetic field due to these 2 parts at center will be 0. So now come to next question. Yeah, see, now there is change of plane, right? So there is change of plane. You have to calculate magnetic field at O, right? This plane is XY plane, this plane is Z plane. This arc is making angle 90 degree. This is also making angle 90 degree. This is also making angle 90 degree. So you have to calculate magnetic field at center, right? This is quarter circle, this is quarter circle, this is quarter circle. So magnetic field at center is equal to, magnetic field at center will be equal to, for this part, see, first you say number 1, number 2 and number 3, right? So what is the direction of electric field? For B1, what is the direction of electric field? For B1, you curl your right hand fingers, your thumb goes inside. Inside means minus K. So B1 is along the minus K cap. For B2, it is in this plane. Z is here. Z is here. Current comes like this. Like this. So your thumb goes. Z is here. Y plane is here. Y is here. YZ plane is here. This is YZ plane. And current is like this. Okay. So you will write current like this. The thumb goes down. Means minus J cap. So B2 is minus J cap. And B3 is in which direction? So this is Z direction. So current goes like this. It is minus I cap. So B3 is along minus I cap. So you have got the directions of magnetic field. Value of magnetic field B1 is 1 by 4 of complete mu naught I by 2R. And for B2, you will write R in place of R, you will write 2R. And for B3, you will write 3R in place of R. So your answer will be B net vector will be equal to, you will just take common mu naught I by 4R. You will write from here mu naught I by 4R. Mu naught I by, it will better to take 8R common, mu naught I by 8R. So you will get R here 1 by R 1 by 1 and into I cap. For this into, for minus K cap. Here it was minus K cap. This was minus, B1 was in minus K cap. This magnitude into minus K cap. And for this 2R, you have taken this 8R outside, minus 1 by 2. B2 was in which direction? Minus J cap. And for this B3 was along minus I cap. It was 3R. So you'll write 1 by 3 K cap. So this is the direction of, this is the value of magnetic field. You can get the mod B here also, and you can get the direction also. So this was the question in which there were 3 quarter circle and they were in the 3 different planes. One was in XY plane, another was in YZ plane, and third one another was in XZ plane, and this was in YZ plane. So first of all, you have to find the direction of magnetic field using your right hand. Curl your right hand fingers, it will get minus K cap. Curl your right hand fingers, it will go minus J cap. Curl your right hand fingers along this. Actually the line which is coming like this is the line like this. So this loop is like this. So you are going like this, then magnetic field is in minus I direction. So it was easy to keep the values and get the direction and get the magnetic field at the center. Now it is very important question. It has been asked many times in various competitive exams. See, there is a wire of length L. From that wire you are making one loop of the circle, and magnetic field due to that is B0. Now you have made n loop from that wire, so n loop, so its radius will be R by n. In this case you will say R1, 2 pi R1 was L, so R1 was L by 2 pi. In this case you have made n loops from that wire, so 2 pi R2 n times 2 pi R2 will be equal to L. So R2 is L by 2 pi n. You can say that if radius of this circle is r, then radius of this circle will be r by n. Very simple, because you have just turned it, taken round n rounds more here, right? So magnetic field formula is mu naught I by 2r. In this case, your r is r by n, and magnetic field due to one wire was b, and due to there are n wires here, so due to n wire it will be multiplied, because if there is 3 loop, then magnetic will be 3 times. If there are 9 loops, magnetic will be 9 times. So if there are n loops, magnetic will be for n loops. So first of all, you just write the formula for this one, mu naught I by 2r. R was r for that and r by n for this. So magnetic field is r by n for this. Sorry, radius was r by n for this, and it was multiplied n times. So this n goes in numerator. So it will get n square b0. So if magnetic field at this point is b0, so at this point it will be n square times b0, because there are 2 factors. Radius becomes r by n, and you have multiplied by n, because there are n loops and each loop has its own effect on its center, so it will add up. So there are 10 loops, you will multiply by 10. There are 100 loops, you will multiply by 100, right? So it was very good problem. Whenever you are just making a loop, single loop from a wire, and you are making n loops, and same current I is flowing in both wires, so magnetic field at center is b0, then magnetic field at that point will be n square b0, right? N square times that much b0. Now it is very interesting again. Now these 2 current carrying loops are not in the same plane. They are concentric, 2 concentric current carrying rings. They have same center, but this was in YZ plane and this was in XZ plane. So this was having current I, this was having current 3I, this was having radius r, this was having 2r. So curl your right hand fingers for the first one. For this one, right hand fingers, magnetic field is this one. B1 is mu naught I by 2r at the center. And curl your right hand fingers for this one, like this. Your magnetic field is along this direction. So B2 is mu naught I by 2r. For I, you will write 3I. For r, you will write 2r. So your formula is 3 by 2 mu naught I by 2r. And mu naught I by 2r was B1. So you have taken mu naught I by 2r is B1. So it is 3 by 2 times B1. Now you have to calculate net magnetic field, right? So B1 is here, B2 is here, B net is using Pythagoras, B1 square plus B2 square, and B2 was 3 by 2 B1. So I have kept here 3 by 2. So you will get root 13 by 4r mu naught I. So it was very interesting problem when there are 2 loops which are concentric and which were in different planes, and those planes were perpendicular. Now we will discuss what will happen if those 2 planes are not perpendicular and they are kept at an angle theta, right? So suppose this is the problem. See, here is one ring, current is coming from this side, and there is other ring like this, like this. Current is coming like this, B1 is in this direction, and there is current coming like this, B2 is in this direction. Angle between the planes of the rings is theta, so angle between their axes will be theta also. So you can calculate B1 using mu naught I by 2r, right? And B2, whatever be the I1 and R1 for them, you should be aware in keeping values. So B1 is here in this direction, B2 is in this direction, so they are kept making angle theta with each other. Now you can make a parallelogram here and you can get B net using formula. B net is root of B1 square plus B2 square plus 2 B1 B2 cos theta. So it is very important problem. Now let us come to here. It is series problem. See, there are infinite number of rings, and they have radius r, 2r, 4r, 8r, 16r, right? and they have say current in same sense of direction, right? Since they have current in same sense, so your magnetic field will add up, color right inside. For every and each this ring, your thumb will go inside, so magnetic field will add up. So mu naught I by 2r. So mu naught I by 2r. For this r was r, then 2r, then 4r, then 8r. It goes up to infinity. There is a geometric series. You can solve it easily and get the answer. Similarly, in this problem, the same problem, but current is alternatively changing. In this, current is clockwise. Here current was anti-clockwise. In this, current was clockwise. Here current was anti-clockwise. So magnetic field is for one circle it is inside, for another it is outside, inside, outside. So magnetic field will be plus minus, and you will get, again you will get an infinite series, and you can solve it easily. Now, use of calculus. There is a spiral. This spiral conductor is having current I. I is flowing through this spiral. Its inner radius is A and outer radius is B, and total number of turns is N, is total number of turns. You have to find magnetic field at center. Since it is changing, radius is changing here, continuously changing, and you have to use you have to use calculus here, right? So see how will we do. You just take an element of thickness dr at distance r. At any arbitrary distance r, you take very small, infinitesimally small this thickness dr. So magnetic field at center will, due to this part, is mu naught I by 2r is magnetic field due to full circle, complete circle, mu naught I by 2r into whatever be number of turns in that element dr. It may be that there are some this rings, some rings are here inside dr. Suppose there are 100 turns, then there may be 5 turns in this. So we have to calculate this. You have to calculate number of rings in this part. So first of all, you should know how to get the magnetic field dB. dB is mu naught I by 2r. This is formula for the complete circle. And how much rings are here in thickness dr? So number of turns in that element dr. You know, you just you observe, this is inner radius is A, outer radii is B, and its thickness is B minus A. In thickness B minus A, there are n turns. So in thickness 1, there are n by B minus A turns. In thickness dr, there will be n by B minus A into dr turns. Right? Simple, it is unitary method. You can solve. Now this is dn. dn is number of turns in thickness dr. So we have taken thickness dr at arbitrary distance r, which has dn number of rings inside that. So dB is due to one circle into dn. dn was number of rings in that dr. So you will write this is magnetic field due to one circle into dn, and dn was n by b minus a into dr. So you have taken all out. It is dr by r. R varies from a to b, and you will get this result. This is magnetic field at center of a spiral. So for this you will use calculus. For this you will use in series. For this you will use vector addition, and for this you will use vector. So there are different, there are formula is same, but there are different concepts. Now the last one, magnetic field due to a point charge moving in a circle. This is a point charge moving in a circle, plus q, point charge is moving in a circle. Its velocity is v. You may given its velocity or frequency or time period of, or its omega, whatever you may be given. But what is the approach? If this charge is moving in a circle, then magnetic field at center is, you have to use mu naught I by 2r. This is q by 2, I is q by t, t is 2 pi by omega or 2 pi r, or you may write 1 by t is f. If you will use t is 2 pi r by v, then mu 0 by 2r is here, I was q by t, q was here, in place of t you put 2 pi r by v, you get this answer, right? And if in place of, it is the same formula, mu naught I by 2r, in place of I you put q by t, and t is 2 pi by omega, then mu naught I by 2r, I was q by 2 pi by omega, you will get this answer, right? Or it may be given that frequency is f, then find B at center, again you use mu naught I by 2r, I is q by t, and 1 by t was f frequency, right? So you will write qf. So I is q by t and I is qf. So in place of I you will write qf. So this is the magnetic field at center in terms of frequency, right? Now what will happen? Now what will happen if this charge q is not point charge? This charge is distributed uniformly on the ring. Point charge q is distributed uniformly on the ring. Distributed uniformly on the ring. So you have to calculate magnetic field at center. It is the same problem. It doesn't matter that charge q is situated at a point or it is spread at in a time t, capital T, in one time revolution at one cross section charge q is passing through. So you will again use the formula B at center is mu naught I by 2r. Charge capital Q is passing one cross section in time t. So I is q by t. In place of t you can write 2 pi by r, 2 pi r by v, or 2 pi by omega, or q by t you can write qf, and you will get the different answers. You will get the same answer but in different terms, in terms of frequency, in terms of velocity, in terms of omega. So this was all about the magnetic field due to current carrying wire at its center. So we have seen the various problems. So I will suggest you to make notes properly and do these problems by yourself again. You just hide the solution, hide the answer, you just see the question, solve it again, and there are many chances of mistake here. Mistake chance, there are many chances. Mistake one is that you may use wrong formula, you may make wrong direction, you may take wrong fraction of the circle. So it is very important to practice these problems. So please, I will request you to practice these problems, make proper notes, and then solve previous year questions of IIT-JEE. I will make more 2 videos on magnetic field. One is due to straight conductor, and next one will be solenoid and toroid. So I will just upload these videos within 2 or 3 days, and I hope from you that you will solve these problems by yourself, because watching videos doesn't work. You have to solve, please. So you solve these questions and practice these questions. I will try to take beautiful and nice questions which are conceptual and which are precise and which are in simulation with IIT-JEE and NEET. So thank you for watching this video. Thank you so much.